CSC there is a macro actually.
Mm-hmm.
In CSC there is a macro where you can construct graphene.
Okay.
So based in the macro you have some like parameter is there, chemical potential.
Okay.
So if you change the chemical potential also, the like permittivity, the properties of the
based on
graphene
chemical
can be
properties.
changed.
Okay.
There we have defined the new materials
Mhm.
in macros. Then they are giving the optical materials.
Okay.
They are defining the
Like
graphene itself.
CST is a kind of bundle where they keep when we go for photonics the tool which we have numerical.
Yeah,
in that we
numerical
have
is there.
Numerical we have. So one thing is then we saw about HFSS 3D layout, the basic structural analysis. Then Q3D, I'll take a model and I'll show you how to see those graphs. Then circuit, just we saw what are the different materials we have. Then it is EMIT. EMIT, as I said, this is again a schematic representation. In this particular model, you can see amplifiers, circulators, filters, all this will be there. What we'll be doing here is, once we place this antenna, like for an example, we are placing for link budget and all, if we are going for, it will ask for which kind of antenna you are going for. If you go by file option, the far field data, whatever it is there, that we can import here. Like for an example, we had already made a far field data from an earlier model, where I had used. Those far field data, if I open it over here, that will be imported here, and I can set the position here, where it should be positioned, how much distance it should be, all these data I will be mentioning here. Okay. So once we are done with this, let's suppose we have made our antenna. So based on these antenna inputs,
Be careful this part.
now we have defined the antenna. For this we will be defining an RF system, that is my radio system. Okay, this radio system, we have libraries. For an example, if you are going for 5G antennas, you will be having a commercial licensed system, where for 5G, like if it is a base station local area, what are the different types of inputs, what will be its frequency, what will be its transmission and reception band, what kind of modulation it will be using. For example, once we go into this, once we double click, you can see it will showcase the band of frequencies here.
Okay.
So the start band of frequency, stop frequency, channel spacing, what is the channel bandwidth, all these things will be shown here. And again, within this, is it a transmission spectrum, what should be the transmission spectrum, how we are defining, all this will be defined, and the same for reception spectrum.
Okay.
So once we define this, for example, if we have designed this particular RF system, then the next thing is we will be analyzing this basically. So similarly, we have
Like what about the input frequency? Like we can define.
it is dependent on the antenna design which we have made. Like we will be using S parameter and the antenna parameters. The peak gain is nothing but we will be deciding the peak gain of that particular antenna. For example, whatever the model which we had made there, the peak gain will be, for example, 7 dB or something. That 7 dB I will be giving here in the transmission spectrum.
So we can change the frequency here directly. That's what I'm asking.
Here in the sense?
So here, like the transmitter part is the RF, right?
Yeah.
So there we can
Transmitter
fix
and
the
receiver.
frequency.
We
Here.
can fix it out here.
Okay.
Just for
The
an
input
example.
signal also we can.
Yeah,
What
actually
the meaning of
you-
board noise.
Hmm?
Board noise. What the meaning of? Actually,
It's simple baud rate, right? Baud noise, right?
some
What did you say?
yeah. This one. Some
It's a baud plug.
Which one you are asking, sir?
Broadband noise, huh?
yeah.
The noise level which we need to define, like
Okay.
how
we have
much
to
the
do
noise
that.
level should be with that signal which we are transmitting. So that
It's okay.
Okay, sir.
So similarly, for example, if you want to go for any kind of new radio system, let's suppose this is the library files. For this we have in commercial based on the spectrum, it is already defined. Then commercial unlicensed, where for Bluetooth, IoT devices, medical and all these things we have set in RF systems. Then for military applications we have a different set of RF systems, and for navigation. So these are the library models. For example, let's suppose you are building a kind of an smart home or something. Okay, in that particular case, you want to find out what is. You can set like this should be the frequency or something. Okay, so in that particular case, if you want to build a new radio, you can go to this particular new radio. Here you need to set what is the band of it. You can set the start and stop band here. What kind of modulation we are going for. Either it should be a transmitting. If you disable reception, it will be just a transmitting spectrum, or a transmitter antenna kind of RF system. It will be working, and all kinds of inputs based on your antennas. It will be here. Okay, so this is basically the EMIT part. How like a general prediction you can make it as like using EMIT you can go for RF interference. If you place multiple antennas, I'll show you a model of a mobile model basically where GSM will be there, then Wi-Fi and other trans receiver, GPS will be there. While trying to make it in HFSS design, how we will be coupling with the EMIT, that I will show you.
Is there any predefined example here available, like component library or something like that?
Open examples you can go for everything. You will be having.
Okay, sir.
There will be lots of open examples available.
Okay, sir.
So the next tool is ice pack. So this particular ice pack is similar, as I said. It is a kind of an representation which we will be making in HFSS first. The 3D model, whatever we are making in HFSS, that we will just export it to ice pack. And the boundary conditions, how we give it in, like let's suppose in HFSS we will be giving a radiation boundary condition, or kind of an PML layers we will be giving there. Okay, so that kind of boundary condition, instead of that we will be giving a temperature dependent boundary condition here. Like at particular wall, what will be the temperature dependent, and it will be basically an external environment, how it will be, that we will be representing there, and based on that our electromagnetic signal will be losses will be converted into heat effect there. So I'll try to showcase a model with ice pack also, where a ring resonator I have an example which we made. So that I'll try to showcase how to start with HFSS and move on to ice pack there. So these are about the overall tools which we have. Okay, so in this, and we have certain procedure which we take it as an thumb rule kind of a thing. Okay, so here the first thing is, these are the steps which we follow in HFSS basically. Okay, so how it is in the sense, insert design is nothing but what kind of is it HFSS design or 3D layout or EMIT, what kind of design we are going to include. And the next thing is solution type. This solution type means what kind of solver I am going to use there. So I had not shown you what are the different types of solvers.
We can define it later also, right? Like
yeah, once you design it also you can make it, but when we are starting what kind of application and what we are going to do, we should be clear on that.
Okay.
Based on that we will be selecting the solver initially itself. So here you can see we have lots of solvers included in this. The predominant solver for antenna design, basically we have HFSS FEM, which is basically an finite element method computational technique which we use here, and based on this is basically based on electrical size of the problem basically. Okay, if the problem size is from micrometer to micrometer to centimeters. Okay, in that particular case we will go with FEM, which is more effective then. Okay, then if it is the problem size in meters, for an example, if you are going to try to place an antenna, you have built an antenna, maximum size of an antenna will be in centimeters, it won't go beyond that. Okay, so if you try to place it on any kind of placement analysis, vehicle or fighter jet or something like that, in that particular case we will be using this particular HFSS integral equation. This integral equation is basically a method of moment computational technique which we use. Okay, so what it will do is
model analysis.
Yeah, it will just model analysis. It won't go for model analysis basically. The FEM, whatever the antenna which has been there, it will be solved by, actually this is